So good morning, everybody.
Good morning.
Welcome back. So we're going to begin this class with a short activity. There are some functions machine that are put in on the table, and there are several alphabets or letters that you need to figure out what the letter represents. So you'll need to get up from your seat, go to the function machine, and figure out what those letters will represent. You have 5 minutes to do that. The lesson today began with a warm-up, which was a review of what we had done the previous lesson, which was a function machine. Seeing a function as a machine that has an input and an output. And they were able to determine the rule or what happens inside the machine that produces the output that it gives out. So the warm-up was in the form of a gallery walk where the students had to walk in pairs and look at different function machine that was placed on the table, and they were to figure out the rule and in some cases determine what the input or the output was. That was a review.
1, 3, 4, 5, 2, 7. So we don't got to worry about them because they done for us. So we got to worry about these and the rule. So that's 0, 0. It's going to be times something because that's 0 and that's 0. So the rule is going to be times something.
What about, no, that can't be.
Because that's 1 and they'll give you 3.5. So,
3.5.
yeah, if it's going in as 1, coming out as 3.5.
2 is.
So what's that, 2.5? So would it be times 2.5? Let's see.
But don't we have 2 rules? Remember that? You remember it was something like
That was
plus.
signs, negative and
No. Like going in, it was like plus 7 and then.
Minus.
I think
But that's not changing the rule. That's the same. That's not changing the rule.
You guys should be working on this. Don't take it up. Don't take it up.
So what do we have to do then?
So I want you to tell me what is A. You tell me what is B. You tell me what is C.
Okay. So we got to get up and do that sound?
Yes, you got to get up and do it. And you can work together.
24 times 6. But it's reversed. So will it be 24 divided by 4? Divided by 4. 24 divided by 4 is 6, right? 16 divided by 4. Divided by 4 is 4. Now we got to figure out what. See, it's not that because B, you can't divide B by 4 and get 11.
It gotta be something.
So now what would be the rule? Then 6 would be C. So
Like
24.
+1 minus 0.5. It gotta be something like that because this is 0.5.
So it's either one of the smaller them.
It's got to be all of them have to be the same. So 24, it's not divided by 4. We got to figure out why B is 11.
So it's a minus.
Well, minus 24 minus how much is 6?
The objective of today's lesson was for the students to be able to see the different views of function. So they will be able to represent function using a function rule statement. They will be able to represent function using a table. And finally, they will be able to represent function using a graph. Now that you've figured out the rule, which is divided by 4, let's take B. It says, what will you divide by 4 to give you 11? B is a number. If you divide it by 4, you will get 11. What is B?
44.
Good job.
44.
So I'm not going to help you with the other one. Go ahead and do C.
So B, so the rule is divided by 4. 44 divided by 4 is 11. And 6 divided by 4 is what? Now how do you divide 6 by 4? How do you divide? It has to be 2, 4. It has to be 1, 2, 1.5. 1.5. Is it, wait, is 1.5? 6 divided by 4, is it 1.5?
So, the function machine, we said when you have an input, you put in something, you get something out. So let's look at this machine. When you put in 24, what do you get out? 6. Perry, are you with me? Yeah. Okay. When you put in 16, what do you get out? 4. What do you think is happening to the numbers? Okay, hold on, guys. Let me hear from this table. You said they're decreasing, subtracting.
Oh, you know
Right.
what? You're right, because of the six.
You said multiplying. Why do you say multiplying? So let's look at this. You put in 24, you get 6.
Yes.
This table, what do you think is happening to the number? Is it increasing or decreasing? It's decreasing. Good job. Decrease can either be minus or division. Okay?
Right.
So put in 24, you get 6. You put in 16, you get 4.
So we're dividing.
Oh, Tina says we're dividing.
Yeah.
Dividing by what?
4.
Dividing by 4. 24 divided by 4 is 6. 16 divided by 4 is
4.
So what is our rule?
Divide 4.
Divided by 4.
So that one right there would be 44.
How did you get 44, Tina?
Because it's, 11 into 44 go 4 times.
Exactly. If this is 44, 44 divided by 4 is 11. So B is equal to 44. Okay?
So that
Let's
would-
stop here and let's go to the next one. Let's look at this one.
That's the one we got right here. Yeah, the orange paper.
This is another function machine. If you put in 20, let's say $20, you get $9.50. It decreases.
Yeah.
If you put in $14, you get in $3.50. What is happening to the number? Hold on, let me talk to this table. Is it increasing or decreasing?
It's decreasing.
It's decreasing. Decreasing by what?
11. What's that? 11.50.
She says 11.50. That is a good one. It is decreasing by 11.50.
It's 11.50. I thought it was 10.50. I thought it was 10.50.
You hold on one. You disagree.
Yeah.
You think it's 10.50?
I think it's 10.5.
10.5. And table 1. What do you guys say? It's 10.50.
That would make it be 21. It should be 10.50. That would make it be 21 if it was 11.50.
So it's decreasing by 10.50. So our rule is 10.50 minus 10.50.
And when I said that, we still couldn't figure
But
it out.
but still though, if it's 10.50, then how we get the 12? I mean,
3.5?
yeah. Oh, cause that mean we put the 0.5 on the out.
On the outside.
Got you.
Okay.
Got you.
So let's look at E, guys.
And we were saying yes.
Valerie, what is E?
I put 22.5.
Valerie puts 22.5. 22.5. So 22.5 minus 10.50 will give you 12.
Why we didn't think outside the box?
No.
Oh, why didn't get there yet?
22.5 minus. It's still 22.5.
Look up, guys. Let's see if it will work. 22.5 minus 10.5 will give you what?
12.
Good job. Valerie is correct.
So the next one is
Okay, guys, we're going to stop here on this function machine. Remember, the rule is you put in something,
and you get out some.
you get out something. You put in something, you get out something. Are we together?
Yes.
So, You can flip your papers over. Let's talk. Look at this function machine. If I put in 4, I get 6. If I put in 5, I get 7. If I put in 6, I get 8. Hold on. What is my rule? Please hold on. Let's try with Bernard. What is my rule? Bernard says +2. Do you agree, Perry? I agree. You agree it's +2? I agree. Why do you agree?
Because when you put in a lower number, you get a higher number out, which means that it decreases. Then you have to find the number what it decreases by.
You meant to say when you put in a lower number, you get a higher number
out,
means it's increasing.
Which means it's increasing.
Okay, that's why you said plus.
And then you find out what the number that it increases by is 2.
By 2. Good. So the rule here is +2. Today we want to learn how to rewrite the rule. Give it a little structure, a little beauty, maybe a haircut, some makeup, so that it will be in the form of a statement. Okay? And this is the format I want the statement to be. Input rule is equal to output. Please write that down. Input rule is equal to output. They already knew what the rule of a function was, but today we try to make the rule in the form of a statement where it leads to what is called an equation. This is how equations were created. It has an input, it has a rule, and then the output. And then we looked at the table, the function table, which was something students were familiar with already. In this situation, what is our rule is +2. So we now say input +2 is equal to output. So this is the way I want the statement to be. Input +2 is equal to output. If my rule is ×2, what will the statement look like? And anybody can say that out. Yes, Tina.
Input ×2 equals output.
Input ×2 equals output. You see, we're giving structure to the rule now. It sounds better instead of saying ×2 or +2. Okay? If my rule was divided by 5, Valerie, how would the statement look like?
Input divided by 5
divided by 5
equals output.
equals output. So because you guys are doing well, I'm going to give you the position of true mathematicians, and you now have the authority to use any letter to represent input or output. For example, if I had my rule to be +3, instead of saying input +3 is equal to output, I decide to use A and B. My input, I call my input A, I call my output B. It becomes A + 3 is equal to what?
B.
It looks more simple. So because just for today, you have the authority to use any letter for that. Okay? So every table is going to create their rule, and we'll take it one by one. So if my rule was -5, Instead of saying input minus 5 is equal to output, this table, come up with two letters you want to use for input and output. What letter do you want to use for input? Give any letter.
We'll use A.
A. What letter do you want to use for output?
We'll use B.
You use B. So what is your statement going to be?
A minus 5 equals B.
Equals B. Excellent. You are creating what is called equations already. Okay? Table 2. Let's go a little bit tough. If I have my input, my rule to be plus, no, let's not use plus. Let's use times 6. The rule will be input times 6 is equal to output. Table 2, give me a letter for input. What do you want to use?
F.
F. F times 6. What do you want to use for output? You said?
E.
E. F times 6 is equal to E. Is there a way we can rewrite F times 6?
You said, can we rewrite?
Can we rewrite F times 6?
No.
If we try to remove the times, when you're multiplying a letter with a number, you can write it as 6F.
Oh, so we can rewrite it.
Yeah. It becomes 6F is equal to E. A shorter version. Without using the times. This is an equation. Just for multiplication.
So only for multiplication.
Yes. And then table 3. Let's say yours is, the rule is times 2 plus 5. That is your rule. What do you want to use for the input?
R
R. It's going to be R,
times 2
okay.
plus 5
Okay, is equal to, what will be your output?
S.
S. Can you rewrite this for me?
Yes.
It becomes
R2 plus 5 equals S.
R2 plus 5 equals S. Let us add a little, do a little rearrangement of this. You always want to write a number before the letter, okay? Because the numbers always want to be first.
Oh, 2R. Okay, yeah.
2R plus 5.
Equals, okay.
You have an equation. So in the coming weeks, we will be looking at different types of equations. You will be creating equations, and we'll be looking at the different types of equation. We will look at linear equations. They're all the same format. We'll look at quadratic equations. But it's always the same thing: an input, a rule, and an output. An input, a rule, and an output. Most of the questions I used were questions I had to adjust during the course of the lesson. So when we talked about the function rule, when I asked them, I wanted to know what they know, and then what do they need to know to get to where we're talking about. They all knew what the function rule is. How do you get the function rules? For them to be able to explain the how, not just the what. It helps the student not just know something, but also understand, and being able to express and discuss their understanding and also explain how they got it. I think that makes learning more concrete and more permanent when it comes to students. Most of the questions were based on what I saw in the classroom, what I saw the students do, and those areas I felt the students needed to learn or unlearn certain things. Now we have given a new name to our rule. Let's create a table, and then we'll look at another way to represent our functions. So one, we can represent a function using a rule, and we use a statement. We can represent a function using a table. We want to look at one other way to represent a function. And that is what we will be doing today. You ready for me?
Yeah.
Yes.
You
A
sure?
little bit.
A little
A
bit.
little bit.
Give us what you got.
Okay. So let's say our rule is +2. Okay? Let's rewrite this into a statement. Let's say it together. 1 to go. Input.
2 equals output.
Good. And let's draw our table. Input, output. If we have 1, 2, 3, 4, 5. Table 1, what would be the output if the input is 1? 3. You said? 3. How did you get 3?
2 plus 1.
2 plus 1 is equal to 3. Thank you. Table 2. I've not asked the question yet. Table 2. What would be the output for 3?
5.
Michael, do you agree with them? 5?
Yes.
How did you get 5?
Trusting they right.
You're trusting they're right.
Yeah.
So if your rule is 2, look at our statement. Input plus 2 is equal to output. How did they get 5? How do you think they got 5?
They plus.
Plus. What did they plus?
2,
Plus 2 plus what?
3.
3. And they got 5. Good job. Table 3. I've not asked my question. What is the output for 5?
7.
How did you get 7, Tina?
5 plus 2 is 7.
5 plus 2 is 7. Okay, now ask me, what's the output for 2? Ask me.
What's the output for 4?
I said 2, you're asking 4. Output for 2 is 4, and output for 4 is 5.
I mean 5. It's 6.
How did you get 6?
Because 4 plus 2 is 6.
Oh, that's true. 4 plus...
Take some back.
So we have our rule, one way to represent function. We have our table, another way to represent function. The third way is through a graph. Taking a deep breath. Taking a deep breath is through a graph. There are usually 2 lines that we draw when we want to draw a graph. Who remembers what those 2 lines are? X and Y. Those are letters. There is always one line that goes from up to down. Hold on, guys. Hold on.
A line graph and a bar graph.
0.
Okay, let me reframe the question and take a deep breath before you answer me. There is always a line that goes from top to bottom and a line that goes from left to right. Remember, mathematicians give themselves 30 seconds to think before they say anything. Because whatever you say now, the line that goes from top to bottom, what do we call it?
Vertical.
Vertical, horizontal? I hear 2. I hear vertical. I hear horizontal. Who is very sure? What? Yes, Tina, what is it called?
Vertical.
Final answer?
Yes.
Vertical. Who agrees with Tina? Raise your hand up. Okay. Chiquita, you disagree? Okay. So this line that goes from up to down is called a vertical line. And then the one that goes from left to right is called what?
Horizontal.
Excellent. I know that Sharon mentioned X and Y, but we will get into that, okay? We will get into X and Y. For now, let us say this horizontal line will be our input, and the vertical line will be our output. The main lesson was now how do we translate the function table into a graph. So we looked at identifying the horizontal and the vertical axes. We didn't call them X and Y. We just labeled them as input and output because that is what is on the function table. So we have our numbers 1, 2, 3, 4, 5. And we have 1, 2, 3, 4, 5, 6, 7, 8. Now we want to draw the graph. We're looking at the input and the output. And this is very important, so stop writing and look at me. Stop writing and look at me. Okay. When the input is 1, what is the output?
2.
We don't know what the rule is.
When the input is 1, what is the output?
3.
You with me? You see where they got the 3 from? It's already on the table. When the input is 1, the output is 3. How do we show that on the graph? I look for input. This is my input. This is 1. My output, this is 3. And I start running towards each other, and bam. Did you get that?
Yes.
You got it? Yes. Let's try the next one. When the input is 2, I said don't write. Don't copy it yet. When the input is 2, the output is what?
4.
I go to my input. This is 2. And then this is 4. And I go up. Bam. Okay? Someone from this table to come and give me the input for 2 and output for 3. Input for 3 and the output. This is our new teacher for today.
You said input for 3, right?
Yes, input for 3.
So start at 3. Do I gotta do what you did?
You must do the da. Is she correct? Good job. Somebody from this table, come and do the output for the input for 4. Who's going to represent this table? You forgot the da. Is she correct? Yes. And somebody from this group, let's do the input for 5. I can't hear the da.
Can you reach that? I know. Here we are.
Is she correct? Yes. Good job, guys. Thank you. So this is another way to show function. We can show it as a rule, we can show it as a table, and we can show it as a graph. Okay? And if you like, you can draw it, connect the dots, and make it a straight line. Okay?
Oh, instead of making all them dots, just go dot with it, point is dot, and then make the line.
So what Valerie is saying is, instead of putting all my da, you don't have to put all those ones. You know that? And then you just put the points. Okay? And at this point, even though we've been using da, let us talk like mathematicians. We'll be using the word points. Not dots. Points. So when you draw your graph like this, for this specific one, it is a straight line. Do you think it is possible? Do you think all the graphs will be straight lines? No. Who said no? Let's hear from Bernard. All the graphs will not be straight lines?
No, it's going to be zigzag.
There's going to be zigzag. Like that.
You're right, like a heartbeat.
Like a heartbeat.
Or wave.
Or wave. Okay, let's hear from you.
Some of them are bar graphs.
Bar graphs. We can also have bar
Bar
graphs.
graphs going straight or
Okay.
horizontal or vertical.
But in this situation, either the graph is a straight line or it is not a straight line. Okay? When the graph is a straight line, we say it is a linear graph. When it is not a straight line, it is called a non-linear. And as we continue in the next 2, 3, or 4 weeks' time, we will be looking at different types of graphs that we create from a function. You will see the one that is a straight line. You will see the one that is zigzag, like the heartbeats. We will also see the one that is like a curve. Anybody seen a graph like that before? Where did you see it? Oh, it's on the GED?
Yeah.
So you will see a line like that. All of them are still based on our function rule, which is about an input, and a rule will give you output. Ready to do some work?
No.
So the next activity we're going to be doing is going to be in groups. So pack up your books. Yeah, you're already in group. Just clear the table a little bit. Each group will have their graph. Each group will have their table and their function rule. And you will create your graph for me. Okay? Make sure you do a nice job.
So it's gonna be like 0, 1, 2, 4, 6, 8, 10. We got enough room to go up to 21.
Go from 1 to 21. Okay, we good.
We could do 2. We could do 2, and do every other one till we get to 21. I mean 22.
Or 1, whichever one.
Well, you can't use 21.
No, I said or 1.
I think
Meaning like 1, 2,
think
3,
it's-
4, all the way to 21.
The 21, that's what I was saying.
like I don't know. I think 2 might be a little better, because if we had like the odd numbers and being as though we skipping them, then we'll have our odd number right there in the middle. You get what I'm saying?
But it make it easier if we was to just do 1 to 21 so they all would be on a line. You know what? If I'm not mistaken, they supposed to be on a line. Or maybe not.
Yeah, but if it's on the line, then we could. If we do 0, that's 0, 1, 2, 3, 4.
So what are
Instead of in the middle
what are we trying to solve here?
Figure out how we're gonna do our numbers up the side. We got our numbers at the input. We try to see what number works best to do the output.
Okay.
But then I thought that, like, when you doing graph stuff like that, you're not supposed to put it in the middle. But I don't know,
No,
maybe
but
wrong.
I know what I'm saying is if this gonna be 2, so that's gonna be 0, 1, 2. So if this gonna be our 2, and then we get something like 3, so our 1 is gonna be 3. That's not in the middle. It's still on the line. It's just an invisible line, but it's still number
Hold on
3.
one sec, hold on. Tina, what do you think? You've been
I don't
quiet.
know, I'm just listening. I just thought we were just supposed to do the numbers 1, 2 through 21, 1 through 21.
Have you guys tried doing that? Just put the numbers 1 through 21 without leaving any space?
Cause we gotta put the dots.
So you try something, if it doesn't work,
Then try
you
something
try
else.
something else, okay?
We ain't get a chance to try it though.
Okay, go ahead and try it and let's see how it goes. My students handled the lesson well. They had a few difficulty, especially in drawing the graphs. They had a few mistakes here and there, even though they were trying to be creative, but they had to learn about, okay, the math way of doing things. That was a learning point for the student. I had to know why they did what they did and how they did what they did. Those were the 2 basic ways that I try to assess them. So why are you leaving spaces in? I'm just asking, why are you leaving spaces in between?
So it can be nice.
So it can be nice.
Yeah, so our line is spaced out. They won't- I
Okay.
mean, if we just put them all bunched up, then it's gonna be like a small graph, but if we spread it, it can be bigger.
Okay. But if you know you have to put the space, you want to make all the space equal. If this is having 1 space, and this is having 3 spaces, so for now, just make it 1 space for all of them. Okay? And then 1, 2, 3, 4 that way, okay?
So we ain't got no space in it.
Yeah, no space in between them. Michael, do you agree with her that the 0 should be there?
Zero.
Start like before, after, 0 and then 1.
Yeah, it's supposed to be about So how do we do?
I'm just asking. So the 0 should be here because it's the start, okay? But if you don't want to write the 0 there, you can write it inside here, okay?
Zero.
Yeah.
So then we have 1,
Michael, are you following? Okay, good.
1, 2, 3. Go ahead. They do 2 to 6. 2 to 6.
We got it on the right line, right? 3 and 1.
Yeah, I mean, y'all gonna be double checking. The only reason I made it so big, I can't see like that. I can't
I
do
just
no
not
two.
complaining about that. We with you. We with you.
All right, now you see,
You gotta connect to make sure the lines,
right, now,
the points are connected.
okay,
No, I'm talking about like this. Take the yards. This how you know if your answer is right. Your points have to connect. You know what I'm saying? Like we just was doing, like he just did.
Our 1 is gonna be 3, that's not in the middle, it's still on the line. It's
they
just
all
a
straight.
visible line, but it's still on the line.
It's gonna be straight, cause that one all the way over there, you gotta connect it. All of them they have to connect.
Right here. Okay, what did I do wrong? Okay, wait a minute, 2 times,
No,
2
3
times
times
3.
1. Oh, you know why?
Oh,
Zero
the 3
times
and the
6 is close. 1 is 0.
Oh,
Zero.
the 3 and the 1 is too close.
Right, and also 0 times 3 is 0. You forgot that. Right, it's 0. Look at the paper, sweetheart. Let me see the paper. You see the first one is 1. Yeah, I told you it was 0 times 3 is 0. That's the first output.
Well, that's what I told y'all. Y'all gonna have to double check it if y'all don't.
That's what we know.
Okay, so now, 0, what go right here?
Okay, one group is done. So we're going to write your names on top, and then we're going to put it up there. And then we'll look at it together. So let's look at each of them. And do they all look the same thing?
No.
How can I give all of you the same table and you're giving me different graphs?
Because some are.
I ain't gonna make that graphs different.
So which of them do you think is the correct one?
The one on the end? Yeah, that one.
Who did this? You guys.
It probably was Perry.
So all of you, Valerie thinks yours is correct. Michael and Sean, do you think yours is the correct one? You said?
I said, yeah.
Bernard says
You
yes.
didn't say what specific, how to make the graph specifically. You didn't say you want the graph so it could be red. So that's what we did.
Okay. This table, do you think yours is correct? Okay. So we're going to talk about each of the graphs, and then you're going to tell us what you did. Okay? So let's begin with this group, since most people think yours is correct. Who's going to explain? You come to the board and tell us why you used the numbers that you used, why you used the kind of spaces that you used between them, and how you came about with your figures. So now I'm going to be a student, and somebody from this group is going to go up and tell us. Can we listen to him, please?
All right, the reason that I drew the graph this way is because the rule was times 3. You put in a number, you multiply by 3 and you get out a number. So if you put in 1, you put it, you can't, well 0 is just 0. So if you do 0, it's just 0. If you put in 1, you multiply it by 3, you multiply it by 3, you get 3. Put in 2, multiply it by 3, you get 6. Put in 3, multiply it by 3, you get 9. Put in 4, multiply it by 3, you get 12. Put in 5, multiply it by 3, you get 15. Put in 6, multiply it by 3, you get 18. Put in 7, multiply it by 3, and you get 21.
Good job. Can you put your hands together for Perry? I have not said it is wrong, neither have I said it is correct. Do you have any question for Perry before I ask my question? Yes, Valerie.
Why do you have an extra
You talking
dot?
about this dot?
Yeah.
Oh, it's not supposed to be
No,
there.
it does supposed to be there. It does supposed to be there.
For the 0?
0 times 3 is
But
0.
it was a dot by the 0, but it was another dot between the 0 and the 3.
No, he put it in the wrong place then.
Okay, so we will just circle this 0, this dot, and we're going to talk about it later, okay? So I have a question for this group. Perry, you can go back to your seat. I have a question for you. And this is my question. Which one is the input? Which one is the output?
The input
It's
is,
where the 7 is.
is
The
on the bottom.
the horizontal line is the input and the output is the vertical line.
But since you did not write it there, and you're not here to tell me, I might be confused. Okay? Since you didn't write it there, and you're not here to tell me, I might be confused. I'll be like, which one is the input? Which one is the output? Okay? So when you do something like this, always label it input and output. Okay? But you guys did a good job.
Thank you.
Valerie, you ready for your group? Valerie and Michael, you guys come up and explain what you did for us.
First, we drew our graph, and then we put input and output. And so after we did the function table, we had the rule times 3. So we put our 0 here, and by the first rule being in 0, out 0, we put the dot there. So then we, well, even though Mr. Richmond told us do not skip any lines, to put it straight like this, we went to 1. 1 times 3 is 3. Then we had 2 times 3 is 6. And then we had 3 times 6 is 9. And 4 times 3 is 12. And 5 times 3 is 15. And then we have 6 times 3 is 18. And 7 times 3 is 21. And then we drew our line and made our ball.
Okay, put your hands together for Valerie. Go have your seat. Question. Ask Valerie any question you have. I've not said it's correct or wrong, remember. I just want you to ask questions. Any question for Valerie? No question? Guys, look at it. No question?
Why is the line going straight up instead of slanted?
So,
Like going straight up. I mean, it's not straight, it's slanted like a little
Like
bit.
the
opposed
straightest
to-
one is that one.
Yeah, the one on that.
The one, the colorful one.
Oh, yeah.
There's the straightest one. But it's still wrong.
so hold on, guys. Ms. Shorter, why do you say it is still wrong? I just want to know. I'm not saying
No,
it's right.
actually, I was talking about that one. I was saying the straightest line is the one with the green dots on it, but it's still wrong.
So you don't judge a graph by if the line is straight or not so straight, okay? That is not what you use to determine if the graph is correct or not, okay? You want to know if the points are in the right place, okay? If the points are in the right place, number one, and then when you number your axes, the horizontal and the vertical, if you number them correctly, you should have a good graph. Okay? Key? Who mentioned key here?
We supposed to have the key over there, that's what we forgot to put the key, which this is the key.
When I did my own, did I write any key? No, so for this one, you don't need a key. So let's call Sean and Bernard. Yeah.
Okay, basically we did the same.
First and foremost, I like the way you decided to use a colored marker to draw the line. It makes it unique. Good job.
Basically we did a basic graph from off the same key. repeatedly. We just squared it all from the square, then started from the 0, did the output up to 21, and the input from 0 to 7. Then we times it by 3 and add our dots and draw the line.
Short and simple. Put your hands together for him. They have. Someone has a question. Chiquita has a question.
I
Yeah.
thought when you were making a graph, the zeros line up at the point, so it should be 1 0 at the corner and not 2.
I squared off the graph.
Okay.
That's why I got the line of the bell, so therefore we could double the 0, so therefore it's being noticeable. It's actually readable,
Okay.
distance-wise.
We designed the graph in our own way, so,
Hold
you
on.
know, so it'll, like, the way we got it, we kind of used it in your way of doing, like the da-da-da-da-da-da, and then da-da-da-da-da, just like that. So,
Okay.
we figured it'd be more beneficial for us as a team. So considering that, you know.
So you see the creativity they did. They decided to make it a 0 here so that it can count for this, and make it another 0 here so that it can count for this line, which is a great idea. Okay, now we're going to talk about if it is the way it's supposed to be done or if it's not the way it's supposed to be done. And that is the thing about math. There is a right way to do something and there is a math way to do something. Are you
What's the
listening?
math way?
I'm coming. There is a right way to do something and there is a math way to do something. Okay? So the right way to do something, you guys are on point. The math way to do something, we will talk about that, okay? But you guys did a good job. Group
Keeping
number
us in
4.
suspense, we still waiting.
Yes.
Mr. Richmond, it's not fair.
No, the reason why,
You took our paper before.
yes, for this group, there was a learning point that I saw, and I told them not to correct it, okay? And I wanted them to explain to the whole class so that we see the reason behind they wanted to change what they did. So who's going to come up for this group to come and talk to us?
Miss Shorter.
Okay.
We didn't line space it from the 0 to the 1. So that kind of threw our line off. But other than that, it's correct, but it's wrong, I guess.
What it's correct is wrong. Put your hands together for her. On the group work, when they created their graph, we had to present it, paste it on the board, and let other colleagues, other classmates ask them why they did what they did. Let them explain what they did, and then we had to challenge a few reasoning behind what they did. That helped the student not just know what they did, but also could defend what they did. Okay, this is why this is not correct. Instead of saying, this is wrong, it is not correct. You could see them being familiar with, oh, so this is how equations are created. It wasn't like something so new to them anymore. They felt like they can actually create equations. When you see an equation like this, most of the time it's based on an input, a rule, and an output. All of you did a great job, okay? Just 1 or 2 mistakes there, and then we will do better in it. Every time you draw a graph, okay, you want the spaces between them to be equal, to be even. So I have from here to here is 1, another one making 2 even, okay? It is not, it's mathematically wrong for me to say 1, 2, and then now put 3 here. What is wrong with this? Valerie, yeah.
You got, for 1, you got 2 spaces in between for 2, but you only got 1 space in between for 3.
It is not even, that is it. And once it is not even like that, your graph becomes like this. It throws everything off, okay? So even if your points look right, because of that, it throws it off. And that was what Ms. Shorter was trying to explain to you all. If you look at their graph, it kind of like began to bend this way, just because of one little point. And they figured it out on time, and they were ready to correct it. But I said they shouldn't so that you all can see it, to show the importance of spacing each number equally. If you decide to use 2 spaces, use 2 spaces across board. If you decide to use One space, use one space across board. It's about treating all the numbers equally. When it comes to graph, you need to treat the numbers equally. If you decide to use two spaces, use two spaces across board. So if I choose to use two spaces for the vertical axis, I will use two spaces all through. If I choose to use one space for the horizontal, I will use one space across board. Okay? Yes.
Does the vertical and horizontal have to be equally spaced or just on that line together?
Good question. What do you guys think? Must it be the same spacing used for the vertical? Must you use the same thing for the horizontal?
I don't think so.
Think so, not too sure, depending on how we use your graph. Let's start with think so. Why do you think so?
So the numbers will add up, right?
So that the numbers can add up right. Okay. You're not too sure. Why are you not too sure?
Because sometimes the vertical can have all the way up to 100 and the input can have maybe 10. So I don't think the line would be.
And you understand the point. If the vertical will have all the way to 100 and you have only like 20 boxes, you might have to make the space different. If this one has up to 10 and you have the whole long way, you might have the spaces also different. So it really depends on what you're working with. Just like Sean said, you made a good statement just now. What did you say?
I say it depends on how you're using your graph.
Depends on how you're using your graph. Okay? So these are situations where you will have to think and make decisions by yourself. The teacher will not give you the decision. The examiner will not tell you what to do. You have to tell yourself, I think I want to do it this way. Any question? No. Back to Bernard's point. Mathematically, you cannot have 1 0 here and another 0 there. Okay? We write it in such a way that it's like it's standing at a bus stop. There is a road going here, there is a road going there. You can stand here and see this road and also stand here and see this road. Okay? And that is what the 0 does. The 0 is like the traffic lights. Intersection. It has to be a place where if it's facing here, it sees the whole street. If it's here, it's facing the whole street.
But again, you did not say how to make the graph. You say you want the graph to read.
Because I wanted you to be creative. So in writing your 0, one of the things I appreciate in Valerie's group is look at where they placed their 0. Under here, where it can either face this way or also face this way. This is the way you place your 0 on your graph. If you look at your paper, there is a column called the solution. And solution means different things. So speaking not as mathematics, when they say a solution, what does it mean? Answer? Okay. Now, in this situation, solution does not mean answer.
It's gonna mean the numbers with the points line on the graph.
Hold on, you have to tell me that again. So we have a solution.
The solution is gonna be the numbers where the points line on the graph.
The numbers that the points are on the graph. So when we talk about a solution in this type of graph, we're not talking about the answer. We're looking at this point, each of these points, what is the location on the graph? Okay? So for this point, it is 1 and 3. Because the 1 connects up and the 3 connects this way. So we write it in parentheses 1 and 3. Okay? For the next one, we had 2 and 4. You write it in parentheses, it is 2, 4.
Do you want us to go ahead and fill in the solution?
Michael, are you with me? Hold on one second. The next solution, you had 3 and 5. So you write it in parentheses, 3, 5. So go ahead and complete. The next one will be what?
4 and 6.
4 and 6, and 5 and 7. So these points are called solutions, okay? When we go further into full graphs, we will give it a different name, but it still means the same thing. Tina looks lost. Tina?
I am lost. What do you mean? How you get 1 and 3 and 2 and 4?
So we look at this.
That's what the input now was plus 2. That's what the points are pointing to. Yeah, 1 and 3, and the rule is plus 2.
We gotta take some points out for that.
So let me explain again to Tina. Each of these points, we want to identify their location. For this point, we created from this. We have 1 and 3, which is 1 and 3. It's actually the input and the output in parentheses. The next point is 2 and 4. Then we have the 2 and 4, which is actually the input and output in parentheses.
I still don't get it.
Put it in parentheses.
Yes,
No, I'm
please.
saying, why do you put those two numbers together?
It is called a solution. So for example, when we, Tina, if I put a dot here, and I tell you, tell me the location of the dot,
Oh, I know now.
what will it be?
Oh, that dot right there is
Yeah.
5 and
It's correct, 5 and
5 and 2.
2.
Oh, you.
But you want to start with the one on the horizontal before the one on the vertical. So it's going to be 2 and 5.
Okay, because so basically it's like 1 plus 2 is 3. 2.
You're not adding it yet.
I know you're not
Yes.
adding it yet, but those are the numbers that you're going to be using.
Yes, that is the location of the point on the graph. Solution is the location of the point on the graph. Let's hear you.
The solution is the in is always first and then the out when you
Yes,
put
the in is always first and then the out.
Okay.
When you're writing the solution, the in is always first, then the out. Now listen to this, guys. Listen. It's like you want to locate, for example, the first time I came to Academy of Hope, I was trying to locate this building, and somebody said, after the fire station, 2 blocks after the fire station, then opposite it. It's like if you want to describe a place, somebody asks you, where is your house? And you say, 2 blocks after the gas station, opposite the bus stop. You're giving the person a location. Okay? You're giving the person a location. And you want to use 2 different things to pinpoint the exact position of the thing. Okay? If I want to give the location of Valerie in this classroom, I can say, if I'm standing here, I will say to my right, next to my right, in front of me. So it's like picking the input and picking the output, using it to describe a point. If I had a point here, how will I describe this point? 5 and 3. So this point is 5 and 3. If I had a point here, how will I describe it? 3 and 3. Those locations, those points are what we call the solutions. Now, when we get into deeper math, we have a different name for it called the coordinates. What do you know about coordinates?
I learned this before. Your X and Y
It
points.
comes into the X and Y points. It's just saying the specific position of
Say like
something.
in military stand.
Pinpoint a location, like on
Pinpoint,
satellite.
yeah.
Pinpoint the location. This time you're doing it on graph. We will be looking at what coordinates are and how to interpret them. Okay? So when you have your rule, your function rule, you have your function table with your inputs and outputs and your solution, and you also have your graph. Okay? Now, there is one more question I want us to quickly look at. I was drawing a graph last night, and after drawing the graph, I forgot my function table, and I can't find it. Implementing the CCR standard has actually helped me as a teacher to narrow down the content to what is exactly important and what is needed. In creating the curriculum, you're always like, what is important for all the students and what is not important for all the students? That is one of the things that the CCR standard has actually given to me as a teacher. Now I know what is important for all the students, because even though it is one thing, it has several branches. We talked about function today, but during the course of function, we saw ourselves mentioning equation. We saw ourselves working with operations. We saw ourselves looking at interpreting a table. We saw ourselves looking at the graph. That means there would have been several areas to delve or channel the lesson for today too. But because of the CCR standards, I know I have a focus. At this level, this is what my students need to know. If you focus on one or two math practices, when you review the lesson in your mind, you ask yourself, did I actually show these math practices? So in that process, it just makes your work more focused, and with time you realize that it becomes a normal thing you do every day. The beginning might be, okay, do I do this or do I not do this? And it's okay if you don't get it right the first time. It is okay. You keep trying again. With time, you just feel the ease of working with the CCR standard. What I want you to do is see if you can create the function table if you have only the graph. Do you guys think it's possible?
Yeah. Say that again.
So, this is input, output, solution. Okay? And this is my graph. Please look up and stop writing and look up. Stop drawing and look up. And I want you to think before you answer this question, okay? So I have this graph. I can't find my function table. I don't even remember my rule. Let's begin with this table. I said stop writing. Is it possible to get my function table and my rule when all I have is this graph?
Yes.
Yes.
This table. Is it possible to get the function table and the rule if all I have is this graph?
Yep. You can.
You said you can, Michael?
Yeah.
You think so?
I think so.
Bernard, you think so?
Yeah, I feel that emotion. I'm with that.
You think so? Sean, you think so? Okay. Sharon, is it possible? You think so? Perry?
I believe it's possible.
You believe it's possible? Are you planning to use magic or math to get it done? Wait. Okay, you know what? Go ahead and create it. Get a paper, create a function table and rule. But before you do that, we have looked at another way to state a function rule in a statement form. Are you with me? I said, wait, do not write. We have looked at how to draw the function table and how to show function in a graph. We have also looked at how to determine if it's the right graph or it's the wrong graph. Okay? And we've also talked about solution, which gives us the pinpoint of a point on the graph. Okay? Right now, we're looking at if you have only the graph, can you create a function table and a rule? And all of you said yes, except me. All of you said yes. So in the next 3 minutes, go ahead and create the rule and the function table.
Oh, you can't.
You can?
Oh, don't be scared, man.
Cause you don't have the rule. What's the
That's what you find. You're gonna find the rule. We about to find the rule. So.
You want to stay with us, don't back out.
So let me work with Michael. Others, you are working, you are not with us. It's just me and Michael that were in the same team. Start with the graph. Don't start with the rule. Based on the graph, can you create a solution based on the graph? You can? Okay, so draw your table. You don't need to draw the graph again. Just look at that graph. Draw your table. Draw this table, the function table. Okay, create the 3 columns. And let's have the solution, input, output. Then let's have your solution. Draw another line, then your solution. Solution. So let's look at the first point. Come. 1, 2. Okay, good. So write it under there. You see the way we write our solution? 1, 2 in parentheses. In parentheses. In parentheses, cover. That's the first one. Look at the next point. What's the next point?
2, 3.
2, 3. Write it. Okay. What's the third one? You said?
3, 5, 3, 4.
3, 4. Okay, write it there. What's the last one?
Nothing. You don't have one on the last one.
I have 4 points there.
Yeah, just 4. So
How many points have you
5,
given?
0.
Okay, come up. Let's go closer. The first one you said 1, 2. How did you get 1, 2? 1, 2. Okay. The next one you said you got 2, 3. How did you get 2, 3? This. So we've done this, we've done this. The third point you got 3, 4. You've got that. The fourth point, what will it be?
4, 5.
4, 5. So write it there. One of the mathematical practices that I focused on the lesson was repeated reasoning. They've been given the input and they have the rule. Now they have to find the output. When we reversed it, they were given the output and now they needed to find the input. It felt like, oh, was there something different? So the reasoning forward and backwards was something the student really practiced during the lesson, especially when they were given. We started moving from the rule to the table to the graph. Then we decided to go the other way, the graph to the table and the rule. And the student demonstrated that they could figure it out in the other way, which was quite interesting. Good job, Valerie. And that is the thing about students' progress. They see within themselves, they see on their work that they have actually learned something. And not just because the teacher said you're correct, but because they see it within themselves and their classmates, their peers also see that, yes, we're doing the right thing. Okay, you're still working out? You're doing well. Yeah, you're doing good.
Mr. Richmond, I feel like you avoiding us.
Let's see. Where is your solution?
Are we going to have a solution?
Good job. So your input is correct, your output is correct, and Chiquita, Shada, unfortunately, that is absolutely correct. Good job. Mm-hmm. We are helping these adults to become better parents, better grandparents, and also help their kids. A lot of them begin to realize that, wow, they can help their kids do their homework. They now understand when their kids bring their homework home. A lot of them begin to think for themselves. For example, when most of the time when I started with my students, they don't want to think about it. They just want you to give them the answer. And now they're beginning to learn to think. And once you practice the art of thinking, you can begin to solve problems by yourself. And a lot of them are beginning to see problems as having solutions. They're happy that they're going back to school because over the years, some of them have been told they cannot make it in school, but now they are giving a try. And a day at a time, they're beginning to enjoy the fact that they're actually in the school and learning something. From the next class, I'll still look at yours. You're not free from me yet. Michael, you're not also free from me. From the next class, we're going to delve more into different types of function rule, where the equation will be different. And we'll go more into the different types of graphs. We'll see some of those zigzags, some of those straight, and some of those bent one. Okay? Any question, like the one you saw on the GED? Any question, always remember, whatever it looks like, even if it's like an equation, it always has three things. What are the three things? Input, rule. Input, output, and rule. Thank you so much. I'll see you next period.